had a few questions prepared about just maybe like your, like I guess educational journey or just your journey to where you are now. I guess the first thing is, like, what was your inspiration for becoming a physicist, like when you were younger?
Yes, okay. Good question. Uh, I was brought up in New York City, in Manhattan, Upper Manhattan, in a region called Inwood. And uh, I was not as sportive as my friends because I wore glasses and I was a bit fat. So I spent a lot of time reading science fiction. And I remember reading it as early as 1943 or so when I was about 11 years old. And the book was, the magazine was called Astounding Science Fiction. And I remember loving it because it was not just science fiction, but it also dealt with science and would try to explain the science that would take place in the stories. One of the stories I remember quite well was written by someone called Cleve Cartmel. It was called Deadline. It was published, I looked this up in preparation. It was published in March of 1944 when I was 12, and almost 12. And in that story, it describes a war between two sides in which one side had an atomic bomb. And it, by God, it was an atomic bomb. It was based on nuclear fission, on the fission of uranium-235, which were, it was in those days known that uranium had these isotopes and that fission had been discovered by the Germans in 1938. So there was nothing secret about having this knowledge. But he wrote this story, and there was then a big fuss because, which I didn't know about at the time, the FBI got involved. And how did you know about this? Because it was just 1 year before, or a year and a half before, the Hiroshima bomb was exploded. And the Hiroshima bomb was exactly a uranium bomb. The next one was not. That was plutonium. But anyway, at the time that the bomb was exploded in August of 1945, jumping now to, I'm now 13, I already knew something about that. And I started explaining to my classmates what had happened because I had read that story, I remembered the story, and I immediately purchased something that was called the Smythe Report, which came out as a book describing the story of the atomic bomb very soon after the bomb was launched. So I had a lot of information. And in other words, at the age of 13, I knew a lot of physics already. So I was not committed to becoming a theoretical physicist. I was too young for that, but I was very interested in science. And before I went to high school, I was playing with chemical sets, which you could buy. In those days, you buy chemical sets. The chemicals were actually dangerous, and you could kill yourself with them if you were careless. Not today, you could take all the chemicals and put them in a soup and drink it, and nothing would happen to you. But in those days, it wasn't like that. So I made explosives, and I made things that smell interesting and look interesting and do all kinds of interesting things. And I convinced my father to build a chemistry laboratory in our basement. We lived in a private house, and there was space in the basement. And he made for me a chem lab, and I did various projects. Then I went to high school. And in high school, I made some friends, a number of friends who would be lifelong friends, who would become physicists. There were lots of us because I, together with my close friends from the neighborhood, did not want to go to the local high school. We all applied to go to the Bronx High School of Science. And I was a student there. And that's where I met Gary Feinberg, who became a friend until he had a premature death and cancer in 1960 or so. So he was at 62. He was a very close friend. And Steve Weinberg, with whom I would much later share the Nobel Prize, the mathematics we had, I was good at mathematics. I not a star, but I was always, I'll get 100% in the Regents exam. That doesn't mean a great deal, but it was a simple exam. So did my friends. But they didn't teach calculus in high school. I was upset about that, but fortunately I had a friend who was a classmate of my age, and he had picked up some calculus, so he explained the basis of calculus to me, so that when I went to Cornell, I already knew some calculus. I could jump into the second semester. Okay, so now among my friends in high school, several of them, Steve, came to time to apply to college. I should talk about applying to college and that sort of stuff. You will be applying to college?
Yes, I'm currently in 8th grade.
You're in 8th grade?
Yes.
Okay, so you have a couple of years to think. Oh, so I'll tell this story.
Sure.
So Steve and I were both rejected to Harvard. However, we were both accepted to Princeton and to Cornell and to MIT. And we were also accepted to the safety school, which was the City College of New York. So Steve's father graciously offered to drive Steve and me to these 3 schools so that we could choose among them. We first went to Princeton. At that time, Princeton had no female students. It was very formal, and the kids would have to put on these filthy black jackets when they went for dinner. They were sort of pretending to be a British university. And we both found it very stiff and formal, and we didn't want to go to a school with no women. So that was how. Then we went to Cornell, and at Cornell we had our first experience to see things like cows and chickens, because we're city boys and we had never been in farms. There's a very big agricultural school at Cornell. There were lots of women. A third of the students were co-eds, as we call them. And the campus was absolutely beautiful. It was on top of a hill overlooking Lake Cayuga, and far above Cayuga, there's an awful smell. I mean, whatever. Then we went to MIT. MIT has no campus, few girls, and no grass. So the decision was obvious. We both chose Cornell, and we both went to Cornell. So both of us from the High School of Science went to Cornell. So did 2 of my other Cornell friends, Kent Gordis and Danny Filson. All of these Jewish, all of these people, Weinberg and Feinberg and me and Kent Gordis and the person who taught me mathematics. By the way, the one who taught me calculus became a professor of physics at the University of New York City, and which was then City College. Feinberg didn't go to Cornell. He went to Columbia. He lived and died at Columbia. He spent his whole life at Columbia. He became a well-known professor. And in fact, he was the person who coined the word tachyon for a particle that moves faster than light. Okay?
That's fascinating.
He did some other good things in physics as well. Let's see, another guy who didn't go to Cornell and didn't go to Harvard, he went to the University of Massachusetts and became a professor of physics there. And he recently died, and I was partly responsible for contacting the small number of people from the class of 1950, that was a long time ago, collecting money, and we managed to collect $20,000 to endow a scholarship, and it was very tricky to do this, but after negotiating, to the best junior student of physics and the best junior student of biological sciences, and those prizes are being given this year, and I hope to hear from Bronx Science about them doing it. But they are doing it. It is happening, and it's guaranteed for some 20 years or so. Okay, so we went to Cornell. Cornell, already at the Bronx High School of Science, Steve Weinberg and I and Gary Feinberg were very close friends, in part because we had to take the subway we could either take a bus or the subway. We usually went home by subway, in which case Steve was with us for just 5 minutes or so because he was 2 stops down the line, but Gary and I had to go all the way down to 168th Street and then back up to 200th Street on the A line. So we spent more time, and our time in the subway was very important because we sort of rivaled one another. We competed. We said, "Oh, I learned calculus. Yeah, yes, I learned variational calculus," and Steve would say, "Oh, but I learned the uncertainty principle." And then Gary would say, "I learned why it is that nothing can go faster than the speed of light." So we had a lot of fun talking of physics beyond what we should be, the level in those days. In high school, it was levers and pendulum and things like that, nothing like atoms and nuclei. So we were much more interested in the latest physics. So there was no question when Steve and I and Gary and the others went to school that they wanted to become theoretical physicists. Actually, Kent Gordis didn't succeed in that. He got diverted into computers, and became the first. There was a predecessor among the financial moguls of the time, a guy named Bernie Kornfeld, who developed something called the Fund of Funds. And if you know anything about the history of finance, that was it was a not entirely honest and slightly dishonest thing, which got scandalously taken over by some other guys. Anyway, Kent was deeply involved in that company, and he sold out. He quit before the scandal hit, and he held on to his shares and became quite wealthy. So I would visit him in years in the 50s and 60s in Geneva, where he drove a Maserati, and we went to 3-star restaurants together, enjoying things that were today quite unaffordable. I have a sample over there someplace, the 1955 Michelin Guide to France, and the highest 3-star restaurant was something like $20 instead of $500. So it was quite a different world. Anyway, so we, having gone to Cornell, Steve and I graduated. He decided to go to Princeton University. I decided to go to Harvard University. And we both had successful careers since. At Harvard, the first thing to do was find an advisor, and there was only one guy there who did the kind of physics that I wanted to do, which was elementary particles. That was Julian Schwinger. Schwinger, if you, I should say, Schwinger would, had, some years later, would win the Nobel Prize shared with Dick Feynman and a Japanese physicist named Tominaga for their work on creating quantum electrodynamics, which is the quantum theory of electricity and magnetism, you know. So after a year and a half or so of taking courses, we, meaning 10 of us, went to Schwinger and said we wanted to be his students. He was well known to take numerous kids as students, but he wanted to know that they knew something first. So he gave us a problem, and we went home and we solved it together, and then came back to him a week later and said, we solved your problem, and explained to him the solution. And he said, right, he didn't really intend us to do that. He wanted us to go and each do it, but whatever. He decided he would do the best he can. So I won't go through all of the students. In fact, I don't remember all of their names. They all became his students. One of them, oh no, forget that guy. He was Spanish, it doesn't count. The rest of them were Americans. My classmate, Charles Summerfield, was he was given a problem in quantum electrodynamics. In QED, there are these things called Feynman diagrams. Now, Schwinger and Feynman were rivals, so you couldn't use the word Feynman diagram when Schwinger's around, but the only way to explain quantum electrodynamics, in my vision, was through Feynman diagrams, so there was a little bit of an issue. In any case, Dirac had come up with his equation, which was the first great action in quantum electrodynamics. It was an equation that is consistent with the theory of relativity that describes the motion of electrons. And it said that the electron is a magnet with spin, and it carries a certain amount of spin, and has a certain moment of inertia. And Dirac's equation predicted the value of that magnetic moment of the electron. It was, of course, measured, and it came out not to agree precisely with Dirac's prediction, which was expected because there would be corrections. And the first order correction had been computed first by Schwinger, and that is the one loop Feynman diagram. And that was great, but nobody had yet computed the second order correction, which was necessary because the experiments were getting more and more precise. So he was given the challenge of calculating the second order contribution, which meant evaluating and calculating about a dozen different Feynman diagrams, which was tough because there were no computers in those days. So all he had was a Martian. A Martian is not an extraterrestrial. A Martian is spelled differently, is a machine. It's a sophisticated adding machine that adds, multiplies, divides, and takes square roots. So that helped, and he used that to do it, and he was the first person to do the exact second order calculation of the magnetic moment. He got a postdoc at Yale. He stayed at Yale, became an assistant professor, full professor, and he spent his whole life at Yale as a well-known theoretical physicist. Then there was Marshall Baker. I'm not going to go through the whole list. Marshall Baker, another Jew, comes from Salem, Massachusetts, and he was given a problem in the strong interactions having to do with the nuclear force, a method of doing calculations called the N over D method. And he did a good job on that, so he went to Stanford for a while, years later, my first teaching job was at Stanford, and he was there at the time, and he got fired the year I got to Stanford because Stanford never promoted anyone in those days. They're better now, but in those days, no assistant professor got promoted to tenure. So I got a little nervous, and I went to the Professor Schiff, who was he's famous because in my day, he wrote the quantum mechanics book that was used in all the different classes. So I asked Schiff if he would, if there was a chance that I would get tenure at Stanford. He said no. Simple as that. So I quit, more or less on the spot. That is, I finished that year. And the next year I went to Berkeley because I knew that at Berkeley there would be no question that if I did well, I would get tenure, and that was in fact true. So I went off to Berkeley. Now I've reached the stage of having tenure, so I can. The rest is more biographical. That's the stuff that's relevant to your interests are done at that point. So let me put an end to that bit of the biography.
Interesting.
So that takes us until 1960s, and that was the time of the free speech movement, or some called it the filthy speech movement, and there was a student rebellion of the 1964 predecessor of the grand revolution of students in 1968, and I didn't mind that terribly much, but I was lonely for home, to my parents living in New York, and preferred New York, the East to the West. So when I got offered a job at Harvard in 1966, I jumped and took the thing, took my Triumph, drove across the country, and took up my job at Harvard. So that's 66. I graduated high school in 1950, got my PhD in 1958, and 1966 I was a tenured professor at Berkeley for some years already, and now at Harvard.
That's cool.
Yeah. After some years, 34 years teaching at Harvard, I quit and I moved to BU because I could walk to my office.
Good reason.
And I stayed there for another 18 years, and then I took early retirement at the age of 86.
Wow, that's a long time.
I still have an office though.
That's really cool. Another question I had is, I guess, out of so many interests and topics that you explore, how did you pick the topic that led you to your Nobel Prize?
You mean a research topic?
Yes.
Yeah, well, I was very, very fortunate because the 60s and 70s were a time of great discoveries in my field of physics, which is elementary particle physics. And I can go through every year and tell you of great at least one discovery made in every year. Now, I don't know if I can do that on the spur of the moment, but I can try. 1964, to pick a random starting point, there was the discovery of the first pion-nucleon resonance, which is indicated that the protons and neutrons are not all that simple. They have excited states. It was the first excited state of the proton. It wasn't realized then that proton was made of quarks, but 1964 was also the year that Murray Gell-Mann, who was also my friend and mentor, introduced the concept of quarks. And it was also the same year, 1964, that I and a colleague whose name will Bjorkane invented the concept of the fourth quark, the charmed quark. That was also in 1964, 3 or 4 months after Murray invented quarks. And 1964 was also the year that a bunch of other people, one of whom I knew because I was at a summer school with him, Peter Higgs, invented the idea of the Higgs boson. That was in 1964. I had nothing to do with that, except that we could have done it when 2 years before together, except he was too busy being in charge of the wine distribution at the summer schools. So it was NATO that provided the wine at the summer school, which was in Scotland. Okay, so anyway, you can see that problems were easy to find because in 64, 65, 66, I can't find something on the spur of the moment in every year, but let's just jump to some crucial years. In 68, the idea of the Higgs boson was discovered. The Higgs boson was looked for many years. You know, it was found on the 4th of July in 2012.
Oh, that's interesting.
It was not an American experiment, it was a European experiment, but there were many European collaborators, so they celebrated the 4th of July with this wonderful discovery. Let me say something else that is interesting to me and maybe not to you. About a year ago, I noticed in the New York Times an article about people whose mind's eye is blind. That is to say, there's a condition called, I forgot what it's called, but I have it. I mean, I'm part of the 2% of the world. So most people can visualize their parents or children or siblings. You can close your eyes and see a picture, or I can close your eyes and see a picture of a chair, or visualize a painting that they like, or in my case, an equation. But I can't do that. I don't have that ability. If you tell me to close my eyes and imagine a chair, I cannot do that. Or a banana, I can imagine a banana, but I can't see it. I know what it looks like, but I can't see a picture of it. But it didn't hurt me very much because I won a Nobel Prize and have done quite well. And I described this condition to my friend who was also a physicist and who won the Nobel Prize in 2017, Barry Barish, who's an experimental physicist, which meant he had to create this device that discovered gravitational waves and thereby sharing the Nobel Prize. He has the same condition. You ask him to close his eyes and visualize a fire engine, he can do no such things. Like me, you close your eyes, it's black. Okay? So that's just an interesting fact. And I don't know, can you visualize?
Yeah, I think so. I've heard of this condition before. It's very interesting.
You thought it was what?
I've heard of this condition before, like just
You heard of
online.
it, yeah.
It's very interesting because it makes me wonder, like, what gives some people the ability to do that and other people's not.
It makes it clear that I can't be an artist because I can't visualize the picture that I would like to create. So though I might have a technical skill to paint it, I can't see it in my mind. It's a strange condition. It's called a fantasia. Okay, where were we? Something happens every year. So when I was at my first postdoctoral experience, I wanted to go to Russia, to what's called the Lebedev Institute, to work with a professor that I had corresponded with, Igor Tam. So that was my plan. I won a National Science Foundation postdoctoral fellowship, which I could use in Russia if the Russians would not pay me, but that was not a problem. The Russians were very enthusiastic. The State Department said, "Yes, fine, you can do that," because in those days you sort of had to make sure everything was okay. But I didn't have a visa, so I wrote to Niels Bohr, who of course I had never met, but I knew that several of my friends had spent postdoctoral time at his institute in Copenhagen. That I asked him if I could come to his institute and work as a postdoc until I would get my Soviet visa. He said, "Sure, come." And I took a boat to go there with another physics friend who was an experimental physicist, Jack Schneps from Tufts University. So we took La France to London, to Plymouth, and that was a pleasant 5 days. It was certainly the way to travel in those days. And there, Jack bought a car, and Jack and I are both Jewish. That's relevant to the story, because the car was not quite ready. It was missing its radio, and they were going to install the radio. So we were told we'd have to wait an hour to get the car in the office of the salesperson. So there we were, reading the documents that were on the wall, the instructions, whatever they were, and there were instructions about. Neither of us could ever forget this. It said, "No short-term insurance policies are to be issued to jewelers and Jews."
Wow.
Of course, we were Americans, so it did not apply to us. But I could not, simply could not forget that. Anyway, we got the car, and we drove off to France, and we barged our way into some physics laboratory called Normale Supérieure in Paris, and introduced ourselves and said we're young physicists. I'm going to Copenhagen, he's going to Rome, and we simply said hello to those guys. And then we looked around Paris, we looked around London, and he went down to Rome, took his car down to Rome. I took trains to Copenhagen, 24 hours by train in those days between Paris and Copenhagen, because it's a little bit faster now, but not much. So we got to Copenhagen with 2 heavy suitcases, and they provided me with now how I got my suitcases, this is something I don't remember. So I have these 2 heavy suitcases. I come to the door of I go to the train station. At the train station, I go to Blijdamsvej 17, which is where the institute is. There I am with my 2 heavy suitcases. I say hello. They warmly receive me. I take my suitcases inside so no one steals them, and try to figure out what happens next. They said they were expecting me, and I have a room in Moltkisvej, which was about 5 miles away. And how do I get there? They drove me there and took me to my new place. And also, it was kind of hard to get from there back to the institute, so they also brought me a bicycle and told me what the route was. So there I was, and I would commute by bicycle to 5 miles. For young guys, that's no big deal. And the weather was not so terrible. And I had to have ideas. So I had an American friend that I had known, Saul Barshay, another guy who was spending a postdoctoral year at Copenhagen. And he and I figured out that nobody had ever figured out a way of measuring the parity of a newly discovered particle called the Xi hyperon. So we wrote a paper on that issue. That was good. Then I had a crazy idea in 1959, the second year I was in Copenhagen, that it might be possible to if there were very energetic neutrinos coming from the heavens, that these hypothetical, well, they were still particles that had just been detected, proven to exist in 1955. So, but they had to exist, and they had to be a component of cosmic rays, and they might be very energetic. And if they were energetic enough, they could make this intermediate, my hypothetical particle that carried the weak interactions that eventually became known as the W boson and was found in the 1980s. That particle, this was still 1960s, that particle could come and hit an electron in the atmosphere and make an explosion which could be detected on Earth. And it was, but it took 61 years. And that was just a couple of years ago that they found the example of what's called, it's not very important, it's kind of prophetic, but not important. It's basic physics that nobody had ever thought of before. It's called the Glashow resonance. That's not a big deal, but it sounds like it should be a big deal because it has a name attached to it. But the next year I had the idea of solving the problem that was the basis to my thesis, was to how to make an algebraic structure that could become a unified theory of weak and electromagnetic interactions. That was the paper, I was told later, it was the one and only paper that was relevant to winning the Nobel Prize, winning my share of the Nobel Prize. And then I wrote a bunch of other papers with half a dozen other papers with other people. I wrote a couple of papers with a Swede, one with a Finn, another with a Pole, Wiesław Cisz. I hung out a lot with physicists from China and Russia, and I didn't write any papers with the Russians, but I got to know them very well. In fact, one of the Russians I met in Copenhagen in 1958 came to Boston to visit me, and I went with him to my good friend from college and graduate school in Copenhagen, Danny Kleitman, who is the husband of one of Joan's sisters. And we went there. I brought this Russian along there, and that's where I met Joan. And that's where I fell in love with Joan, at that dinner. So years later, I went back to Moscow, and I met this good friend of mine, and he helped me pick out an alexandrite that I could bring back as a ring for Joan.